Now that we've learned why these identities are true, let's take a look at some examples of simplification. So I do want you to notice that first off the directions are to simplify. So we're going to take these expressions and make them shorter. So the first one we have is tangent squared. Notice that that is an exponent of 2. So tangent squared of pi over 2 minus x. So right off the bat, remember pi over 2 is just 90 degrees. So we're doing 90 minus x. This right here tells you that it is a cofunction identity. We'll just call it cofun over sine of x. So we just have a simple sine of x on the bottom. Now remember, the reason it's called cofunction is because they're in pairs. And the easiest way to remember it is in pairs. So if you remember when we learned this identity, tangent pairs with cotangent. That's easy to remember. So therefore that tangent of pi over 2 minus x is the same as cotangent. So really all you have to do, as complicated as this looks, is just change this to cotangent of x. Now because it's being squared, that won't matter, right? Because it's just the same thing multiplied by itself twice. So the exponent doesn't really have much of a bearing in this problem. So step 1 is to simplify using cofunction and even-odd identities. This is a very simple lesson. So basically what happens is the pi over 2 minus x goes away, and this becomes cotangent. That's one way to remember it if you really don't care about where it came from. However, that I do, okay? So that's why I spend these videos explaining why these cofunction identities are true. So that's just going to become cotangent of x. The squared's going to remain there. And we've completed step 1. So I'm just going to put a big check there. It's very, very simple. And by the way, when we're simplifying trig expressions, we're doing this in an order. The order we're doing this matters, because you're going to see when you get to the end and you're simplifying some complex trig function, the order will matter, okay? And the order of cofunction and even odd will matter. For example, if you're trying to simplify something like that goes alongside of a Pythagorean identity. So now that we've changed this, what's our next step? Well, the next step is step 2, which is to simplify using Pythagorean identities. So let's take a look at this. Would you use a Pythagorean identity to simplify this? Well, no, right? Because there's no 1 plus, right? And there's no like sine plus cosine squared equals 1. There's no cotangent squared minus cosecant squared, or whatever that identity was. I can't even remember right now. But however, if you look back at that lesson on simplifying Pythagorean identities, once you use a Pythagorean identity, then you resort to quotient identities. So you have to kind of keep that lesson in the back of your mind and realize that part of simplifying using Pythagorean is to also use quotient. So perhaps I can kind of use a slash here and say simplify using Pythagorean / quotient. Basically any identity we've learned up until this point, you should be familiar with using for this next step 2. So since Pythagorean identities don't apply, we're going to switch to quotient. Remember that cotangent is cosine over sine, so I'm going to change cotangent squared to cosine squared over sine squared. Now we're still going to have the sine on the bottom, that didn't change. But now we will flip. We will keep the top, change the division to multiplication, and flip the bottom to 1 over sine. We will end up with cosine squared on top and sine cubed on bottom. Now, that's one way to think about it. However, basically what you notice though, remember you want smaller exponents when you're simplifying these things. So at the end of the day, we can convert this back into cosecant squared because basically nothing canceled out when we did that. It was basically an unnecessary step. I'm just showing you that when we do expand it all the way out, it's a good practice to do that, right? Cosine squared over sine cubed, that's gonna, if we add up the exponents of 2 and 3, that's a total exponent of 5, and we want smaller than that. And we can do that because if we keep this as cotangent squared over here, we can just change this, and that's an exponent of 2. We can change this to just cosecant, which is an exponent of 1, which is total exponents of 3. And that's going to be our final answer. So this was what we originally started with, tangent squared of pi over 2 minus x over sine of x. And the final answer is cotangent squared of x times cosecant of x. I want to use some parentheses here. That can be a bit of a bother. Your final answer should not contain pi over 2 minus x, because cofunction identities take care of that. And notice that the final answer is, in fact, much simpler than the original. Not only is it not a fraction anymore, but it actually has the same number of same exponent numbers, and it took away that pi over 2 minus x. That's it for this example. Remember, step 1, use the cofunction / even odd identities to simplify the first part, then use the Pythagorean / quotient identities to simplify the second part. And our final answer is cotangent squared x times cosecant of x. If you have any other questions about this example, let me know.